Good evening. Hi. I'm Jerry Baldesty. I'm the interim provost and executive vice president. Welcome to the 40th annual University Faculty Lecture. Every year, the University of Washington faculty members select one of their peers to present this distinguished lecture. Over the past 4 decades, we've seen an impressive list of presenters give this prestigious lecture: historians, doctors, artists, engineers, and many others. This is the highest honor that the faculty can give to a member of their own ranks. And so this is a very special evening for all of us. This year's recipient, Donald Grayson, has been an anthropology professor at the University of Washington since 1975, teaching archaeology both in the classroom and in the field. He's a true leader in his profession and has been so for decades. He's researched and written extensively on a variety of sites, time periods, and subjects. But he's most recognized for his research in southwestern France in the Great Basin of Western North America. In addition to his academic work, there are many students who can speak to the impact of his teaching and mentorship. Some of these would be the undergraduates who enjoyed his classes on the prehistory of the arid West and prehistoric extinction. Or they might be among the 22 PhD students he's mentored throughout his career and he has helped them find fulfilling employment across the country. He's an incisive and thoughtful leader. He cares deeply about his discipline and the people whose lives it touches. Aside from all of this, he's also an engaging, thoughtful speaker who inspires curiosity in students and peers alike. We are so lucky to have you here. Please join me in welcoming our University Faculty Lecturer, Professor Donald Grayson.
I will try to live up to part of that. The picture on the bottom of the screen is a picture of a mammoth being excavated in the Black Rock Desert of northwestern Nevada, the same Black Rock Desert where the Burning Man Festival is held. Almost everybody who grows up in this country learns about this particular animal, mammoth, alongside animals that lived with it. Saber-toothed cat is an obvious example. A mastodon is another possibility. More recently, if anybody has seen the movie Ice Age, you've seen what I actually think is someone who knows something about these animals are really good, perhaps caricatures of these animals. Manny the mammoth, Diego the saber-toothed cat, Sid, the giant ground sloth. Everybody's heard of these animals to one degree or another if you've grown up in North America. That may be all you know. You may not know when they became extinct. You may not know why they became extinct. And I will say now, although we're going to come to this later, if you have heard that they became extinct because they were hunted to death by human hunters, I would claim that you still don't know why they became extinct, but I will return to that later. These extinctions have been the focus of research for over 200 years. In fact, some of these animals, including the mammoth and one of the North American ground sloths, was critical around the year 1800 in establishing the fact that extinction could actually occur in the first place. By the 1870s, the great evolutionary biologist Alfred Wallace was able to point this out, what's up on the screen, that sometime in the recent past, the Earth had lost some of its hugest, fiercest, and strangest animals. He marveled at this. If he were still alive today, he'd marvel at it even more. He'd marvel at it even more because we know so much more about these animals than we did when he was alive. But he'd also marvel about it because we still don't understand any more than he did why these extinctions occurred. I'm going to focus on North American extinctions here. North America lost 37 genera of mammals as the Ice Age came to an end. When Wallace said that these were recent disappearances, in modern terms, he could have said that these were late Ice Age disappearances. The Ice Age is the period of time that lasted from 2.6 million to 10,000 years ago. It was characterized by the alternating advances and retreats of massive glaciers on many parts of the Earth's surface. The extinctions that I'm going to talk about were extinctions that occurred, I'll be general about it now, between roughly 30,000 and 10,000 years ago. There's only one term that I have to define besides Ice Age, and that's the term genera that I just used. Everybody has run across this term, the term genus, the plural is genera. Similar species are lumped into, grouped into a genus in biological classification. Genera are grouped into families, and so on up the hierarchy. Once having defined that, I can go back to what I just said, that toward the end of the Ice Age, North America lost 37 genera of mammals. It'd be fun to just talk about North America. It is fun to just talk about North America, but I also want to point out that it wasn't only North America where this was happening. It was happening in Eurasia, but more important for us, it was also happening in South America, where 54 genera of mammals were lost. Because some of the North American mammals were also found in the south, and some of the South American mammals were also found in the north. If you count up the total number of genera of mammals that were lost, you get 77. That is a huge part of biological diversity to have been lost at the end of the Ice Age. And as I said before, we're still trying to figure out why and how that happened. In addition to that, and this is going to become really obvious as we go along, one thing that characterized these losses is the fact that the animals were all big. All is a bit of an overstatement. 3/4 of the animals that were lost weighed 100 pounds or more. We'll see that some small ones also went out of business, but we're also going to see that the overwhelming majority of these animals were really, really big. My goal today is to spend an hour, I'm going to look at my watch and see when that's going to be up, trying to clarify some of these issues. And I know that I've got more to talk about tonight. I could talk about this stuff forever. I teach a whole course in this stuff. I know I've got more stuff to talk about tonight than we have time to talk about. And when the hour is up, I'll just stop. As I said, 37 genera of mammals were lost from North America. 6 of these, and we'll see what they are, horses are one of them, live on elsewhere. But when they became extinct in North America, they never appeared here again unless they were reintroduced later on. I'm going to give you a rundown of all these guys, and I'm going to start with the cingulates. Think armadillo. Cingulates are animals with external bony armor. These are South American animals, some of which, just like armadillos, made it north. There are 2 animals very closely related to armadillos called pampathirs. If you saw one, you'd immediately think armadillo, but you'd also think something else that I can't repeat here because of the size of these animals. This is an armadillo that was 6 feet tall, 3 feet long, weighed between 500 and 600 pounds. I am not, by the way, making any of this up. Northern pampathirs were southern animals. They made it to southern North America. The southern pampathir, about the same size. There's its shell, but this is a South American shell. Southern pampathirs are not as well known from North America, but they did make it here. Then there's this next guy, Glyptodont. Glyptodonts are also South American. These are armadillo-like in the sense that they also have external body armor, but unlike the armadillos, this external body armor is not flexible. These guys had carapaces like tortoises. They also were almost literally the size of Volkswagen Bugs, the cars. Weighed 2,400 pounds, that carapace was fused to their inner skeleton. They hung around water. These were absolutely remarkable animals. I don't know if you can see that picture on the lower left. If I start free associating like this, we'll never get through anything. But if you can see this picture on the lower left, I stuck it in here because I love it. This is a picture of a glyptodont that was a reconstruction of a glyptodont that was made in the 1930s for work being done by famous paleontologist George Gaylord Simpson. In the 1930s, it was already known that some South American glyptodonts had tails that ended with mace-like projections. But in the 1930s, they'd yet to find the end of the tail of the North American glyptodont, so they hid it behind a bush because they didn't know what it looked like. Once it was found, it was discovered that its tail ends without the mace-like projections. It's simply rounded. This is its distribution. Sid the Sloth. The movie Ice Age amazes me. I've actually looked on the web to see if I could find out who knew enough about the Ice Age to do those reconstructions, because they're really good. There's a glyptodont in there. There are South American animals in there that North Americans generally have never heard of. It's a great movie. Sid the ground sloth is meant to reflect the fact that North America during the late Ice Age had 4 genera of huge ground sloths. Today, when we think of sloths, we think of slow-moving, tree-hugging animals that, if they're fat, may weigh 20 pounds. That is not the case for the North American ground sloths, and the North American ground sloths, as a whole, are smaller than the ones that went extinct in South America. I'll start with Megalonyx, Jefferson's ground sloth. Here's a reconstruction done by a very talented paleoecologist friend of mine, Wally Wolfenden. We'll be seeing a bunch of his reconstructions today. This is a reconstruction of Megalonyx. Its name means great claw. It was given that name by Thomas Jefferson in 1797, and you can probably see why he called it that. He called it that because of these great claws. He didn't recognize it as a sloth, not surprising. This is 1797. He thought it was a carnivore. He was wrong about that. He also didn't realize that it was extinct. He argued that if it had once existed, it must still exist. And as I said before, some of these animals, including Megalonyx, were used to argue that extinction was real. When Jefferson was writing, he did not yet believe that that could be the case. Megalonyx, widespread in North America, as you can see here, coast to coast. This one, in my extinctions class that I teach, I have an election every year. Not as fancy as the one I had this year. This year's was really fancy. We had a primary election, and then we had the final election to see which of these 37 genera the students, I voted 2, all of us, would most want to see if they could see one alive. I voted for Glyptodonts. My students got it wrong, and they voted for Eremitherium. Eremitherium had the height of a giraffe and the bulk of an elephant. It is eastern in distribution, mostly southeastern, though there's one curious record from coastal New Jersey that you can see on this map. If I had to have a favorite sloth, it would be this one, Nothrotheriops. It is shown here eating the fruits of the Joshua tree. It's shown that way because we know that it ate those fruits, and we know that it ate those fruits for something I'll talk about in a minute. This was the smallest of the ground sloths, the smallest of the North American ground sloths. It was also western in distribution. By the way, I'll point out that odd-shaped blob that you see on the west side of the map is a region called the Great Basin. If we have time tonight, if I don't free associate too much and run over time, I'll talk about the Great Basin towards the very end. That's the distribution of Nothrotheriops, the smallest North American ground sloth. We know what it ate because we have its turds, if I can say that. Here's one of them. Nothrotheriops, the Shasta ground sloth, had the friendly habit of pooping in caves in the dry west, in the arid west, including caves in the Grand Canyon. This particular one comes from Rampart Cave in the Grand Canyon. You can pull these things apart, you can identify, you can radiocarbon date them, and you can identify the plants that are in them. As a result, we know a lot about ground sloth diets. And just to free associate, there must be men in here, and I'm saying men because this is more common in men than in women, men in here who get kidney stones. Most kidney stones are oxalate kidney stones. I get them, so I'm familiar with them. Most of them are oxalate kidney stones. Yuccas and agaves are loaded with oxalates. When these pieces of dung were first analyzed in the 1930s, a botanist and a chemist combined to do it, and they discovered that these things they did the chemical analysis and discovered that these things were also full of oxalates. And those oxalates are coming out of the plants that they were eating. How ground sloths didn't get kidney stones is beyond me. I'd love to know. This is Paramylodon. This is the fourth of our ground sloths. This is the most abundant ground sloth at Rancho La Brea. It's part of a family called the Mylodont ground sloths, all of which are characterized by the fact that their skins have little bony pebbles embedded in them. In fact, that skin that you see on the lower right was found in the late 1800s in southern Chile, and it led to the possibility that ground sloths might still exist, and to an expedition to find them still on the hoof. They didn't, but every so often that possibility reemerges. Perhaps the argument is they still exist in the deep Amazon. In North America, they were clearly gone by 10,000 years ago. That's the distribution of Paramylodon. We even have Paramylodon footprints from, and I'm not making this, this is going to sound funny, but it's true. This dot right here is the Nevada State Prison. And there were footprints found there in the late 1800s that were thought at first to be human footprints, and within a decade or so were recognized to be Mylodont ground sloth footprints. They're the only footprints of a sloth, as far as I know, that are known from North America. The carnivores. Smilodon, the saber-toothed cat, is one of the iconic mammals of North America, along with the mammoth. But there were 7 genera of carnivores that were lost. The short-faced skunk, paleontologists are really good at giving common names to animals. The short-faced skunk is called that because it's a skunk with a short face. It's not very well known. There are only 7 sites of it known from North America. Kuon, the dhole, is a hypercarnivore that is doing okay, not great, but okay in southern Asia today. During the Ice Age, it was found from northern Spain all the way across into northeastern North America, northwestern North America. And then if you look closely, you'll see that one site in Mexico, way down here. Every so often, somebody gets it in their mind that that can't possibly be Kuon, and they go look at it, and sure enough, it is. It has to. These were not birds. It has to have lived someplace in between. All the work I did in the Great Basin, the site's been known for a long time. I would always have my eyes open for Kuon. It's an animal that I would run across in the Paleolithic sites that we worked on in France. Nobody's found one in between. It had to have been there. Somebody will find it sooner or later. Tremarctos, the Florida cave bear. Tremarctos still exists. It's called the Andean bear. It still exists in the mountains of western South America. I believe there's one in the Seattle Zoo. It's also called the spectacled bear. This is a South American bear with its closest relatives, and its distribution during the late Ice Age was South American. It was closely related to this guy. Oops, wrong button. This guy, the giant bear. The giant bear is called that for a good reason. The giant bear was the largest land carnivore of the late Ice Age anywhere in the world. I put 1,500 pounds on there for its weight, but there are some whose weight has been estimated as high as 2,000 pounds. People argued for a long time about what its diet might be. Argued is the wrong term. Pondered, did research on what its diet might be, and in the end, we've learned so much about it that the conclusion's obvious. This bear ate whatever the hell it wanted to. Widespread. coast to coast and up into the northwest, although one thing that we know is that these records in the far northwest date to the 20,000s, while ones down here date to as late as about 11,000 years ago. They seem to have become extinct up here before they became extinct down there. The saber-toothed cat, one of the animals, Diego, in the movie Ice Age. Massive, massive animals, weighing 500 pounds, larger than an African lion, with those long sabers protruding from its mouth. The sabers had serrations on both sides, like pinking shears on both sides, narrow, powerful cutting tools. These animals also had really powerful front limbs, built in such a way as to be able to resist twisting motions while they're killing their prey with their front limbs. These animals were probably ambush hunters, lurking for their prey to walk by. There are also 2,000 of them, roughly, at Rancho La Brea. That fact suggests that they were probably social as well. A probably social pack-hunting animal. There's their distribution. I should say with all these, this is their known distribution, right? Surprises can always be in store. Homotherium is called a scimitar cat. It also had those protruding teeth, but they were smaller than the protruding teeth of the saber-tooth. Homotherium was really widespread in the Ice Age, Africa all the way across down into South America. Homotherium was a long-legged, powerful cat, short-tailed, long-legged, powerful, short-tailed cat, pretty clearly ran its prey down. We know that it could hunt animals as big as juvenile mammoths because in a cave in Texas, it's been found associated with its prey. That's its distribution. And then there's this guy, Miracean onyx. This is such a cool animal. This is a type specimen from a site excavated in northern Nevada, not far from Pyramid Lake, Winnemucca Lake Basin. This is the very skull that led to the definition of this genus, Miracean onyx. It's called the American cheetah, and it's called the American cheetah because this animal is so similar in so many ways to African cheetahs that for a long time it was thought that they were really closely related. Some even thought that maybe cheetahs evolved in the Americas, crossed into Eurasia, and ended up in Africa. People who live in the Northwest, have been in the eastern Washington, eastern Oregon, Nevada, the Great Plains have probably seen pronghorn antelope. Pronghorn are the fastest herbivores of North America. They can reach bursts of speed of 60 miles an hour. There's nothing that can catch them. There's nothing that can come close. Why is this animal, it's reasonable to wonder, over-engineered? Why are you able to run 60 miles an hour when nothing like that is needed to get away from your predators? Well, the guess is, and a guess is all that it is that the pronghorn is over-engineered for today, but it wasn't over-engineered for the past. That pronghorns evolved with American cheetahs. And their speed is accounted for by the fact that slow pronghorn became dinner to the cheetah, fast ones escaped. Here's the distribution of Miracean onyx, American cheetah. It's western. The one thing I meant to say and forgot is the fact that fairly recently, DNA has been extracted from its bones, and we know that western cheetahs aren't closely related to African cheetahs at all. They're related to our cougars. They are similar to cheetahs because their adaptations are similar, not because they share a recent common ancestor. The giant rodents, they're so cool. Giant beavers were the size of black bears. This is true, they're size of black bears. Different people reconstruct their weights at different amounts, but these were beavers the size of black bears. Mostly eastern in distribution. They don't seem to have been dam builders. Their teeth don't match the dam building habits of modern beavers. Mostly eastern in distribution, but a couple of sites in the far northwest. And then these guys, capybaras. Capybaras today are the world's largest living rodents. Big males can reach 120 pounds. They still exist in Central and South America. Here's a family group of them. One of my students in my extinctions class pointed out to me, I didn't know this a couple of years ago, that they're bred to be pets. There's a totally, if you Google capybara plus pet, you'll come up with totally cool YouTube videos of capybaras living as pets in people's houses. If you do that, look closely and look at the wood in that house. There's one YouTube. Rodents have ever-growing incisors. They need to keep their teeth worn down. There's a door in one of the houses in one of the YouTube videos that's almost totally destroyed by a chewing capybara, but they are, to their credit, totally cute. They hang around water because that's how they tend to escape predators. There are capybaras they are southern animals, South American animals. Capybaras made it into southern North America during the Ice Age, as did another genus of capybara, this one, which was at least 50% bigger than the modern capybara. This is a capybara also found in South America that pushed 200 pounds. Here's our second animal, our second small animal. Our first small animal was the short-faced skunk. Aztlan elegus, the Aztlan rabbit, was about the size of a pygmy rabbit. Pygmy rabbits are fairly well recognized in Washington state because there was an isolated population in eastern Washington that people are now working hard to reintroduce in the Hanford area. Aztlan elegus was a western rabbit. It was about the size of a pygmy rabbit, but it didn't behave like pygmy rabbits. Its postcranial skeleton, its legs, suggest that its behavior was more like a jackrabbit, that it was an efficient runner. There's its distribution. What doesn't show on here are records south of South America. This animal is known deep into Mexico. Horses. Many people here probably know that horses evolved in North America. They crossed into Eurasia over the Bering Land Bridge. They also moved into South America, where two different kinds of horses existed until the end of the Ice Age. They subsequently became zebras in Africa. They continued to exist in Eurasia obviously, they still exist into historic times, but they became extinct in North America about 10,000 years ago, only to be reintroduced much later by Europeans. They were all over the place. Let me point out that whenever you see a picture like this one, that's showing an archaeological association. This is the archaeological site of Wally's Beach in southwestern Alberta, which has artifacts associated with an extinct horse. I'll come back to that later on. Tapirs. Tapirs evolved in Eurasia and then moved into North America and into South America. Don't know how many species there were, maybe as few as 2, maybe as many as 4, but they were found from coast to coast. The flat-headed peccary. What's on the screen here is an animal that's known as Catagonus. It was discovered by scientists in 1975. When it was discovered, when scientists discovered it, it was thought to be Platygonus, the flat-headed peccary, because it looks so much like it. Its skeleton looks so much like it. There's no question that Platygonus, were we to see it on the hoof, would have looked like this. This is the Chacoan peccary from the Argentinian Chaco. I should have said that. Flat-headed peccaries would have looked very much like this. Platygonus was widespread, coast to coast. There's that one record in the far northwest in the American Arctic. There's now a second record. It's not been published from the northern Yukon. It's not been published, so it's not on here, but there's no reason to doubt it. So a widespread peccary. We also know that this peccary was a herd animal. And we know that because often when you find one skeleton of Platygonus, you find a bunch more with it. That's very different from the long-nosed peccary. The long-nosed peccary, when you find one long-nosed peccary skeleton, that's all you find. This pretty clearly was a solitary animal. It was also an animal that you find in the wooded, primarily in the wooded east. Camels. I know some of this is hard to believe. I've been working with these animals since graduate school, and I still find some of this hard to believe. I'll start with camelops. Here's a reconstruction by Wally Wolfenden of camelops. If you saw one today walking down the street, you'd swear it was a dromedary. There are some differences. Its head's a little bit longer, a little bit skinnier. Its hump is a little bit further forward. It's a little bit taller, but it looks like a dromedary. And genetic ancient DNA, the analysis of ancient DNA from its bones, which was just studied, shows that it's more closely related to Eurasian dromedaries than it is to South American llamas. It was a Western camel, quite common. There have not been many Pleistocene age, Ice Age sites in the Great Basin that I've worked on that didn't have camels in them. This is Wally's Beach again. Wally's Beach has artifacts associated with both horse and camel. The other two extinct camels are both llamas and llama size. Hemiakinia was widespread. It was also a herd animal. We know that again because we have found herds of them dead. Paleolama, not as widespread, southeastern in distribution. Navajoceros. This is the first reconstruction ever to have been done of Navajoceros. Wally Wolfenden and I did this together. I did the anatomy. Wally did the hard part, the part that takes talent. He drew this. When I saw this, I thought it was remarkable because this animal is exactly how I would have pictured this. This animal is not all that well known. It was between a deer and an elk in size, but it had the bulk of an elk, of a very large elk, and very simple antlers. It's called a mountain deer because its skeleton suggests that it was a really nimble climber. Its skeleton has been compared to the skeleton of a mountain sheep. There's its distribution. Cervalces. This is often called the stag moose, found in two very different places in North America. Major distribution, obviously, in the east around the Great Lakes, and then a very isolated distribution up here in the far northwest. These animals are found in habitats that would be identical to the habitats in which you find moose today. In fact, their postcranial skeletons are the skeletons that's not the skull, are very similar to the skeletons of moose, so much so that they can be very hard to tell apart, but the antlers are distinctly different. Sooner or later, and sooner is probably closer, the genetics of this animal are going to be known, and my guess is that it's going to show that these stag moose are closely related to stag moose, Cervalces, that occurred over here in Eurasia, and that these are genetically distinct. Nobody's done that work yet. So here is a moose-like animal that was not a moose. Many of us have seen pronghorn. I can't say we've all seen them, but many of us have seen pronghorn. Pronghorn existed during the late Ice Age. One of the things that makes pronghorn distinctive is this. Wow, what did I do? One of the things that makes I need 3 hands. Pronghorns distinctive is this prong on their horn. That's why they're called pronghorn. Pronghorns have only 2 horns, a left one and a right one. They existed in the late Ice Age, during the Ice Age, but they existed alongside 3 other pronghorns, all of which had 4, not 2, horns. Capromyrix was the smallest of them. Capromyrix would have been about that tall, 18 inches to 2 feet tall, and weighed about 25 pounds. The other 2 were pronghorn in size. The difference between the other 2 is that in one of them, the horns were of equal height. In the other one, the horns were of unequal height, with the front horns shorter than the hind horns. Capromyrix, reasonably well known. It's an easy animal to identify because it is a tiny little pronghorn. Western North America. Tetramyrix, not as well known. There you can see a complete skull on the top right there with those shorter front horns. Stockoceros is better known. There aren't that many sites of it, but some of the sites that have provided the remains of Stockoceros have provided the remains of dozens and dozens of them, 50 to 60 individuals. As a result, its skeleton is really well known, and as a result, we know that these were herd animals. There's no way that Caprimyrex, the tiny one, the diminutive pronghorn, could have been a herd animal for the simple reason that it would have been too inviting a target for a predator. Caprimyrex was probably, the diminutive pronghorn, was probably an animal that saved itself by stealth, and it probably had protective coloring. Saiga. Saiga are a sad story in the sense that Saiga were doing poorly for a long time in historic times. People launched a major conservation biological effort to save them. It was working, and then just recently, they got really slammed by disease. It's an awful story. They still exist in southern Asia, but during the Ice Age, their distribution went from northern Spain, southern France, we find them in the sites that I used to work on in southern France, all the way across into northwestern North America. Eucerotherium, the shrub ox. It also had the convenient habit of pooping in dry caves in the arid west, so we know a good deal about its diet. We know, for instance, that it was a browser. It's also western in distribution, and we know from its genetics that it was reasonably closely related to the modern muskox. Boetherium. Boetherium, for reasons I'll talk about in a minute, is called the helmeted muskox. You can probably maybe even see why up there, that heavy mass of bone on its head. Widespread. You find it in the far northwest, the Arctic. You find it from coast to coast. It was found pretty much every place in unglaciated North America except the far southwest and the far southeast. There's why it's called the helmeted muskox. For a long time, this animal was divided into two different kinds, the genus Symbos and the genus Boetherium. People began to realize that, gee, when we find one, we often find the other. Maybe there's something going on here. And what's going on is that one was the girl and one was the boy. The girl has horns like the modern muskox has horns with a split down the middle. The boy has horns that look like that, buttressed horns that are clearly meant to be used in head-butting battles for male dominance. If you look at these horns, you can see something else here, and I think this is really cool. See how these horns curl outwards? This is the male, while these are curving forwards. These horns are made for headbutting. These horns are not. The headbutting was meant to be just headbutting. You weren't meant to hurt the other guy. You were meant to intimidate the other guy. These horns curl outwards, so when these guys headbutt, neither of them is getting stuck by horns. The female horns point forward, perhaps because that's a more effective way to ward off predators. I won't talk. Oh, we're doing good for time. That's the kind of thing you're supposed to say to yourself and not out loud. I won't say much about Mixotoxodon. The toxodonts are South American animals. We know from very recent research that they're most closely related to horses and rhinos, but they are South American. Until prior to the year 2013, we had no idea they got this far north. In 2013, Ernie Landelius, a very famous paleontologist, published the first record for a toxodont in North America from eastern Texas. He told me about this 2 years before it was published, and I thought Ernie, who's quite old, had lost it. It just didn't seem possible, but there's the tooth. This is a toxodont. Ernie will never lose it. He's right. This is the only specimen we have for this animal in North America. The next one down is in southern Mexico. Mammoth, mastodon, everybody's heard of mammoths. Many of you, maybe even all of you, have heard of mastodons. I'd be surprised if many of you who are not in the business have heard of gomphotheres. Gomphotheres were the South American version of mammoth and mastodon. Mammoth and mastodon did not make it south of Panama, the Isthmus of Panama. South of there, the proboscidean, the elephant-like animal, was the gomphothere. That's what its jaw looked like. Gomphotheres are characterized by the fact that they had these really complex cheek teeth. These are a lot like the cheek teeth of mastodon, but they're even more complex than their cheek teeth. You can see how big they are. These were massive, massive animals. Gomphothere specimens have been known from North America for quite some time, but only recently, and I mean really recently, was it realized how long they lasted in North America. We now know that from this site called El Fan del Mundo, that gomphotheres survived in North America until about 11,550 years ago. This is called a Clovis point. It's associated with the two gomphotheres from this site. Here's the site. This site was excavated by Lupita Sanchez, you see her name here, and Vance Holliday. Vance Holliday was the one who provided me with these illustrations. There it is right there. There they are excavating that gomphothere mandible that you just saw. And here are what are called Clovis points. I'll show you another picture of these in a minute because I want to talk about Clovis for a minute. Clovis is one of the most famous archaeological phenomena in North America. It's probably fair to say that Clovis is one of the most famous archaeological phenomena in the world. Clovis dates to between 11,600 and 10,800 years ago. It has an artifact that is totally diagnostic. When you see it, you know what it is. When you see it, you know how old it is. When you're an archaeologist and you find one, you never forget where you were when you found it. They are splendid artifacts like pronghorn. They seem to be over-engineered. People were importing raw materials, gorgeous raw materials, all over the place to make these beautiful specimens. Here's a cast of one that I'll come back to in a minute. They are primarily, Clovis sites are primarily sites of the plains and Southwest. When people argue that the animals we've been talking about were driven to extinction by human hunters, it's Clovis hunters that they mean. Oops. One of the things that characterizes Clovis is the fact that they made what are called caches. Nobody knows why they did this. They're amazing things. They dug holes in the ground and put artifacts in them and left them there. I'm mentioning this one because there's a famous Clovis cache in eastern Washington near Wenatchee. It's called the Ritchie Roberts site, or the East Wenatchee Clovis cache. There are about 24 of these known from North America. The Ritchie Roberts artifacts are on the second floor in the Burke Museum. Not all of them, but enough of them to make it worthwhile to go see them there. There's also a great ground sloth skeleton, megalonic skeleton in the Burke Museum right near the Ritchie Roberts artifacts, found when they were digging the SeaTac airport. That one has a radiocarbon date, as I recall, of about 12,000 years ago, the museum one. Mastodon. Mastodons are quite different from mammoths. I'll point it out in a minute, but mammoths have these high domed heads. Mastodons lack that. These are low, long, tank-like animals whose tusks jutted out kind of horizontally and whose teeth were much more complex than the teeth of mammoth. Here's their distribution. There are 2 archaeological sites from North America that have both mastodon and either Clovis age artifacts or Clovis points themselves, or Clovis dates, some combination of those 2 things. I put this up here just to remind me of this amazing fact. There's a mastodon known from the Wasatch Range of Utah at 9,800 feet elevation. People who are interested in this stuff may notice that I've only got 2 sites here that I'm willing to accept as associated with Clovis Age artifacts or Clovis Age dates. What's missing is this site, the Manus Mastodon site. It is a very famous site in Washington State. It's near Sequim, Washington. It's now on a set-aside. It's being preserved. The little museum in Sequim, you can go see the mounted skeleton of the mastodon from there. Here's the artifact. No, wrong thing to say. Here's the specimen that started the big deal about Manus. Many people think that this is also a human-associated site, and they think that because of this particular bone. This is a head of a rib. Here are the articular surfaces where the rib would have joined with a vertebra, the backbone. And here's this thing that appears to be sticking out of it. Many people think that this is the tip of a bone projectile point. This, by the way, is, I took this picture in, I shouldn't tell you when, but 1977, when this was excavated. This is the way it looked as soon as right after it came out of the ground. This is the way it looks today. This is from a paper published in Science in 2011. This is the location of that rib and this thing sticking out. You can see the computerized X-ray, the CAT scan there. It looks like a pointy thing. The argument is that this is a bone projectile point sticking into a rib. I am unconvinced, and here's why I'm unconvinced, and I'll just let you read this. This is a must battle between 2 male elephants. Not only do we know that male elephants do this, we know that mastodons did it because there are mastodons known from the Great Lakes area with skeletal damage that only could have been done as part of this kind of battle. That skeletal damage includes broken, shattered vertebrae. It is fully possible that this piece of bone sticking into the Manus rib is part of that animal's own skeleton. Until it's shown otherwise, I am not willing to accept this as an archaeological object. Mammoth. We're almost done with our tour. Mammoths. The second iconic mammal of the North American Pleistocene. People talk about 2 to 4 species of mammoths. It's now looking from ancient DNA that all these guys could probably interbreed. These were massive, massive animals with massive, massive tusks. There's that dome on its head that was meant to receive the muscles that ran back to its vertebrae to hold up these massive, massive tusks. It looks very different from a mastodon. 11 sites have been found that have associations between Clovis artifacts and mammoth. There is no question that people were hunting mammoth. I've been talking only about the genus level here so far, genus level extinctions, and I've been doing that because often it's so hard to tell what a properly defined species is with extinct animals. For horses, the genetics suggest that there may be as few as 2 species. There may have been as few as 2 species of horses during the late Ice Age. Paleontologists have defined some of them 10 species, some of them 20 species. So nobody disagrees about the genus. A horse is a horse. But there were 3 well-defined species of animals that went extinct in North America. The dire wolf is one of them. The genus Canis still exists in North America today. Wolves, for instance, and coyotes, and humankind's best invention, the puppy dog. They all belong to the same genus. Dire wolves were widespread. They had massive, massive muscle attachments for the muscles that operate their killing mechanism, their chewing mechanism. They were widespread. They were clearly social. There are 2,000 specimens of saber-toothed cats at Rancho La Brea. There are more than that of dire wolves at Rancho La Brea. When one got stuck in the tar pits, bunches of them got stuck at once, suggesting they were hunting together. These were pretty clearly pack hunters. They were pretty clearly able to take down animals as big as bison. Panthera leo. This is still hard to believe, but it's still true. There were lions in North America during the late Ice Age. Lions were extremely widespread at one time. The Americas all the way over into Africa. The difference about the extinct American lion is that it was bigger than the modern African lion. The genus still exists in North America because jaguars are still found in southern North America. And then there's the mountain goat. People here know about mountain goats. They were introduced into the Olympic Peninsula, where you can see them today. They're mammals of the northern Cascades and northern Rocky Mountains. There was a very separate species of mountain goat found in the southwestern U.S., the Great Basin in the southwestern U.S., for instance, in the Grand Canyon. We know that it had white fur because that material has been found in dry caves in the Grand Canyon. It was smaller than the modern mountain goat, but it was also a nimble, agile animal, just as is the modern mountain goat. Well, that's my not-so-quick rundown. I have 12 minutes left. That's my not-so-quick rundown of the players, the late Ice Age mammals of North America. One thing that I have been kind of avoiding so far, except to give you a general notion as to when they became extinct, is the chronology, the timing of their extinction. Remember, one of the arguments for the loss of these guys is that the root cause are Clovis hunters, that people entered North America. The first people in North America were Clovis hunters, and that they hunted these animals to death. That means that all these animals must have existed during Clovis times. The problem is that we can only show that 17 of these 37 genera of mammals made it past 12,000 years ago. We pretty much know that they were all gone by 10,000 years ago because there is not a single compelling date from any site in North America that has these animals much below 10,000. But less than half of them can be shown to have coexisted with Clovis. Some of these animals, their most recent date, predates 25,000 years ago. What we can be sure of is that all these animals were around 25,000 or so years ago. All of them were gone by roughly 10,000 years ago, and a lot of them, but not necessarily all of them, were going out of existence between 12 and 10,000 years ago when Clovis people were around. The age-old question is why? The obvious answer is climate change. I have published a ton on this topic. People always associate me with the climate change group, but the truth is that nobody has made a coherent, compelling argument that climate can explain all of this. And I'm just going to leave it at that. There is another explanation that's quite recent that you may have heard about. It made the popular media just as, kind of sexy science often does. That argument is that a comet exploded above glacial ice in the Great Lakes region of eastern Canada and caused these extinctions. That is, the extinctions are due to an extraterrestrial impact. In fact, that argument is not only that the extinctions were due to an extraterrestrial impact, but that the end of Clovis is to be explained by an extraterrestrial impact, as are a wide range of other things, including continent-wide burning, for which there is no evidence, massive climate change, and a bunch of other things. All I want to do is show you one slide. This is the chronology of the latest dates for mammoth in the area where Alaska and Eurasia come closest together. It's called Beringia. Remember, that comet is said to have exploded 10,900 years ago. If that's the case, their argument is that these extinctions all occurred around 10,900 years ago. Whoops. But as you can see here, our latest date for Alaska is 11.5. They're probably younger ones. Maybe they made it to 10.9. But our youngest date for a mammoth in mainland northern Siberia is 8,700 years ago. St. Paul Island, 5,700 years ago. And amazingly enough, the youngest date on Wrangel Island for a mammoth, and these are really good dates, there's over 100 dates on mammoth from Wrangel, is 3,700 years ago. An impact event of 10,900 years ago, which caused all these extinctions, doesn't work. And also remember that, this is one of the reasons I mentioned South America when I started, 37 genera became extinct in North America, 54 genera became extinct in South America, all the way down to the tip of Tierra del Fuego. It's hard to imagine, even without the slide I just showed you, an impact event explaining all of that. Well, then there's this. We may not have time to get to my avocado. There is a really intriguing relationship between mammoths and avocados, gomphotheres and ground sloths and avocados. But I promised I would only go an hour, and I only have about 8 minutes left. Human predation is clearly the most common argument that you encounter for these extinctions, that Clovis people did all of these animals in. The argument isn't that Clovis people hunted the carnivores to death. The argument is that Clovis people hunted the herbivores to death, and that because of that, their predators died. That saber-toothed cats and scimitar cats and American cheetahs died because people did in their prey. I'm no fan of that argument. And I'm no fan of that argument for reasons that I've actually kind of already mentioned. Reason number one is this. We can't even show that half these animals made it into Clovis times. That's reason number one. Reason number two is this. There are 37 genera of mammals that became extinct, 7 of which are carnivores, 30 of which are herbivores. Of those herbivores, we can only show that people were associated with them in such a way that they were probably hunting them. We can only show that for 5 of these animals. Here are the sites. We have one site with a camel in it and a horse in it. We have one site with a gomphothere in it. We have 2 sites with mastodon in it, and we have 11 sites with mammoth. And that's it. You saw, I'm sure I would be gratified if you remembered the distribution of ground sloths in North America, but in case you've forgotten, if you add them all up, all 4 of them, they were all over the place. There's not a single archaeological association with ground sloths in North America, even though they seem to have been everywhere. There are other reasons I don't like these arguments, but these are the prime ones. We can't show that people were hunting these animals, yet they are said to have hunted them to death. We can't show that all these animals, or even half of them, coexisted with people, yet they are said to have hunted them to death. Well, unfortunately, the conclusion to all this is that we simply don't know what caused the extinctions. The nice thing about this may sound odd, the nice thing about this is the fact that we don't know what caused the extinctions drives people nuts, and because it drives them nuts, it causes them to learn more and more and more about these animals. Are you bored yet? It's 8 o'clock. Avocado, okay. We've all seen reconstructions like this. This is a 1972 reconstruction from the National Geographic. It doesn't matter that it's, 40 years old? There are the animals. We've talked about all of these, and let me point something out. I just said that there's not a single association between artifacts and ground sloths in North America that is in any way convincing. Nobody even argues there is one. There wasn't one in 1972, but so deep is the assumption that people cause these extinctions that, if you look here, those are people hunting a Jefferson's ground sloth. There is absolutely no archaeological associations anywhere between Jefferson's ground sloths, megalonyx, and people. This drives me nuts. But this is the view. Didn't show this to foam at the mouth. This is a common view. Here are some more of them. Okay? These are the reconstructions that you see of the North American Ice Age landscape. It's got the landscape teeming with animals. Until relatively recently, I kind of pictured the American past this way. I let myself think by analogy with the African plains, the African savanna, that North America was just covered with animals, just like is shown here. This, by the way, is from the Great Basin, an area that we're going to talk about in a minute, a high elevation Great Basin. And so, let me quickly talk about this. I think 5 minutes is about right. Let me quickly talk about this. North America has 4 botanically defined deserts. One of them is the Great Basin Desert, right here. 3 of them are probably better known: the Chihuahuan Desert, the Sonoran Desert. I think of these 2 as Walt Disney deserts. This has saguaro cactus. This has Joshua trees. These are the 3 warm deserts of North America. The cool deserts, warm summers, cold winters. The warm deserts, hot summers, warm winters. Here's what the lower elevations of the botanical Great Basin looks like, kind of like parts of eastern Washington. Sagebrush, and before livestock were introduced, grasses. Here's what the Chihuahuan Desert looks like. I'm not going to talk about it anymore. Loads and loads of creosote bush. Here are Joshua trees in the Mojave Desert, kind of an iconic plant of the Mojave Desert, and saguaro trees in the Sonoran Desert. These are the warm deserts. The Great Basin Botanical Desert has a diverse late Ice Age fauna. 20 genera of animals, all of which we've talked about, here are their pictures, are known from there. It also has a really well-defined archaeological record. One of the 2 earliest sites known from the Americas is from the Great Basin. It is from eastern Oregon, called the Paisley Caves. It has human fossilized feces. I said turds before, but I don't want to say it again because I shouldn't have said it. Dated to 12,400 years ago, from which human DNA has been extracted, Native American human DNA. This is one of the 2 oldest sites known from the Americas. The other is a site called Monte Verde in southern Chile that dates to 12,500 years ago. The earliest diagnostic, obvious artifacts from the Great Basin are also known from the Paisley Caves. They're known from everywhere, but they're best dated from the Paisley Caves and date to 11,100 years ago. These kinds of artifacts are also associated with this cool thing called a crescent. They're widespread in the Desert West. We've got a really good archaeological record from the Great Basin. We know that people were here by 12,400 years ago, and that they were using points that look like this, artifacts that look like this, by 11,100 years ago. We also have a good radiocarbon record for the extinct mammals, and because of that, we know that people were in the Great Basin at the same time as at least these 7 genera of now extinct Ice Age mammals. We know that people were living in the same places where those animals live. That is, they overlapped in dates and they overlapped in habitat. And this made me wonder a couple of things. There is no association between artifacts and an extinct mammal whatsoever in the Great Basin. None. None that people even argue about. There are no kill sites from the Great Basin. That made me wonder about how often people saw these animals. Were they as common on the landscape as this reconstruction, this common kind of reconstruction suggests, or were they rare on the landscape? Well, that made me think about an article that I read I read it before 1982. Richard Mack and John Thompson were botanists at Washington State. I think Richard Mack is still there. They sent me a manuscript when I was a young puppy and said, what do you think of this? And I read it and made some comments on it and thought it was cool, but I just didn't get how important it really was. What they pointed out was that, unlike the Great Plains, let me put this differently, the Great Plains has grasses that are adapted to being eaten by large herbivores like bison. The Great Basin doesn't. This is what they pointed out, that the Great Basin lacks widespread grasses that do well when they are chewed by large herbivores, when they're grazed. That's why when you go to the Great Basin today, in areas that have cattle on them, you see hardly any grasses in the valleys. They concluded that large grazers of the sort that we've been talking about here, these large herbivores, were never abundant there. Well, it only took me 30 years to realize that maybe this is worth thinking about. And what I started thinking about was this, pointy, dangerous things on tall plants. Plants that my colleague Connie Millar calls ouchie plants. Connie is sitting right there. Anybody who's a gardener, there they are right there. Anybody who's a gardener, when you prune your roses, you come away with stuff that looks like this. Well, imagine being a herbivore trying to eat one of these things. So I'm talking about plants that have spines, thorns, anything that if you try to eat it, it's going to hurt you. Their function is clear. They're meant to provide a mechanical defense against large herbivores. Well, guess what? The warm deserts, Mojave, and I'm not going to worry about the Chihuahuan. The warm deserts of Western North America, the Mojave and Sonoran deserts, have over 100 species of these ouchie plants, these mechanically defended plants, spread across 21 different plant families. They look like this, cat claw acacia, there's its distribution, or this, or this, or this, with these very pointy, spiky leaves. These are plants that have that armament to keep large mammals from eating them. How about the Great Basin? There's only 6 species and 6 families of these things in the Great Basin. Here are 3 of them, whoops, here are 3 of them with their distributions. That's a huge difference. Over 100 species in the warm deserts, only 6 species in the Great Basin, cool desert. Somehow you cross a boundary when you go from here to there, from tall plants that are mechanically, from the lack of tall plants that are mechanically armed to an abundance of them. And by tall plants, by the way, I mean plants that are over 6 feet tall. Lots of them down here, hardly any of them up there. I am calling that the mechanical defense line, because that's what this represents, a line that bounds a place where plants are defending themselves with mechanical devices. Obvious question to ask is what created this line? Obvious answer is that it was created by climate. After all, we're going from a cool desert to a warm desert, or vice versa. And sure enough, when you look at the history of these plants, that does explain some of it. For instance, yellow palo verde, Parkinsonia, doesn't reach its northern edge of its distribution until about 4,000 years ago. It had to wait till it warmed up, till it could get that far north. But that doesn't account for all of this. Cat claw acacia, with those really scary things, cat claw acacia was in the Grand Canyon 22,000 years ago, during the late Ice Age. Joshua tree was at the northern edge of its distribution by at least 18,500 years ago. Climate can't account for all of this. What I think does account for it is the distribution of huge Ice Age herbivores, the animals these plants were defending themselves against. Here are the heights of a subset of those 100 species. There's no herbivore today that can reach up 50 feet and eat the top of an acacia plant. Doesn't happen. Here are the heights of the biggest herbivores in arid Western North America today. And just to be as fair as I could, I included bison on there, even though bison are looking down to eat, not up. These animals are not tall enough to account for these tall, mechanically defended plants. The animals that can account for this are all now extinct. So my guess is that as we move north from down here, up into this area, the Botanical Great Basin, we move from an area where these animals were relatively common to an area where they may well have been quite rare. That perfectly matches the argument that Mack and Thompson made in 1982. Well, when I first made this argument, I don't remember if this was in Word, if I was talking to this person or sent him a manuscript that talked about this. None of this is published yet, by the way. He asked me, this is Dave Rohde, a paleobotanist, one of my own students who's often done this to me. He said, don't extinct herbivores ever look down? By which he meant, why are you only looking at tall plants? Why don't you look at the short ones also? That annoyed me, number one, because I hadn't thought of it. Because certainly extinct herbivores would look down. And number two, because it meant a lot more work, and I thought I was done. So now, rather than looking just at the tall mechanically defended plants, I looked at the short mechanically defended plants. And guess what? There is no distribution, no difference in the distribution of these plants. Short plants are armed, mechanically armed, as often in the cool Great Basin desert as they are in the warm southwestern deserts, leading me to wonder why climate would matter to a plant that was 7 feet tall, but not to a plant that's 5 feet tall. The only thing that can explain this is the height of the herbivores and the abundance of the herbivores that existed in this area in the late Ice Age. So this is the argument, and I promise I'm almost done. I've gone 1 hour and 2 minutes. But we've reached this. I've noticed when I walk down the Ave holding an avocado, people applaud. Now maybe I understand why. There's an avocado. Avocados are amazing. These are obviously our, kind of domesticated avocados. But the difference between wild avocados and this guy is the pulp of the fruit. It's not in the seed. The seeds of the wild ones are this big. This is obviously an avocado seed. You see a fruit like this or a seed like this? The obvious question to ask, if you're smart enough to ask it, and I wasn't, it was Paul Martin and Dan Jensen in the 1980s who asked it and answered it, is, here's a big fruit with a huge seed. Why? What could have possibly eaten this and distributed the seeds across the landscape? Well, it's things like gopathirs, ground sloths, mammoths. They're all gone today. It's called a megafaunal fruit. Megafaunal fruits are large fruits. There's lots of characteristics of them. Large fruits with large seeds. The seeds can pass through the guts of an animal and still be able to germinate. In fact, some of the seeds of megafaunal fruits have to pass through the guts of an animal to be able to germinate. That's the avocado story. When you buy avocados, when you eat guacamole, think to yourself that this plant clearly evolved in the presence of gopathirs, ground sloths, and other large things that were eating it and distributing its seeds. Well, there's at least 10 different species of plants with megafaunal fruits in the warm deserts of the Southwest. There is not a single one in the Great Basin. That matches the distribution of mechanically defended plants and Mack and Thompson's grasses. Sloth poop. Shasta ground sloth poop. Many people think, and that includes me, that the dispersal mechanism for the large fruits of Joshua trees, these fruits are characterized by the fact that not only are they large, but they don't break open on their own. They're called indehiscent. They don't break open and spread their seeds. Many people think that one of the prime seed spreaders of yucca trees, of Joshua trees during the late Ice Age was the Shasta ground sloth. It would eat those fruits, it would wander across the landscape, it would drop this someplace else, and Joshua trees would emerge. That, they argue, is why we have a distribution of Joshua trees that looks like it's declining. That is, that the primary disperser of this plant is now gone, and as a result, the plant is in retreat. And sure enough, the late Pleistocene distribution of Joshua trees looks like this. So that means, to me, as we go north in the arid West, we go from an area where large mammals may not have been common, but they were common enough to lead to that diverse set of mechanically armed plants and to plants with megafaunal fruits, to an area where large mammals, may have been quite rare. Well, the other question to ask is this, and I'm not going to answer it because I'm done, but the other question to ask is this: did any place in America actually look like this? There was recently a reconstruction of biomass, the number of animals on the landscape in Alaska, that determined that Alaska didn't, not only, how to put this, that a version of Alaska that looks like this vastly underestimated what Alaska looked like. In fact, we don't know that for any part of North America. The next question to ask in this vein is just that. Is there any place in North America that looked like this? And as part of that, the other question that's going to continue to be asked is, what in the world caused the extinction of all these things? And with that, in an hour and 5 minutes after I started, thank you. Thank you.